Welcome to the Explainer. So, have you ever interacted with an AI and just thought, man, you are really not getting me? It's a super relatable frustration, right? You ask a system to draft an email or maybe summarize an article, and it gives you a perfectly acceptable, grammatically correct response that just completely misses your personal tone. It misses your unique context. It's kind of like wearing a one-size-fits-all shirt that doesn't actually fit anyone perfectly. Well, today we're exploring a fascinating new research paper titled One Adapts to Any. And what I found absolutely compelling about this is how it provides an actual roadmap for fixing exactly this problem.
So we really have to ask the obvious question right out of the gate here. Why doesn't your AI truly understand you? Well, the reality is that standard large language models are trained using what's called a monolithic objective. During their alignment phase, researchers basically aggregate feedback from thousands of different human annotators and just average it all out. So the model learns this generic set of preferences that's broadly acceptable to the vast majority of people. It's trained to be safe, helpful, polite, but in a very standardized way. But as you and I both know, human values are wildly diverse. Your preferences are totally different from mine. By optimizing for everyone, the AI essentially optimizes for no one in particular. It acts as this generic assistant instead of giving you a custom experience.
And that brings us to the whole concept of personalized alignment. The goal here is tailoring model behavior to individual needs and your unique preferences, basically throwing out that single monolithic objective. But there's a massive roadblock here, and it's the core problem we're unpacking today. It's the sheer scarcity of feedback. See, general AI models learn by analyzing thousands, if not millions, of preference examples. But let's be real, you and I simply don't have the time or the patience to sit down and grade thousands of AI responses just to teach the system our unique quirks, right? We really need the AI to figure out who we are from just a handful of interactions.
Okay, let's dive right into this. Section 1. Why current methods fail.
Now, engineers have absolutely tried to solve this before, but there are two main paradigms that just keep hitting a brick wall. On the one hand, we have the personalized input approach. This is where you try to force personalization by feeding the AI a massive system prompt all about your persona or your past preferences. The problem? It completely fails under sparse feedback. If you only give it a little bit of context, the AI relies on a really coarse, superficial approximation of who you are. On the other hand, we have the personalized parameter approach. This involves training specific, separate model parameters or adapters just for you. But this struggles immensely to adapt to new, unseen users. Why? Because training parameters from scratch with only a few examples leads straight to overfitting. The model literally just memorizes your few inputs and totally fails to generalize. So we're stuck in this inescapable dilemma. We have scarce feedback, but we still desperately need deep, robust adaptation without breaking the model.
As the researchers so perfectly put it, and I love this quote, this dilemma implies that current optimization paradigms are inadequate and calls for a fundamental shift in perspective. Basically, we have to stop lazily trying to just fit data. We need a totally new narrative arc that moves us away from static training and pushes us into the realm of learning to learn.
Which brings us to Section 2. Learning to learn through meta-reward modeling. And this brilliantly illustrates the proposed paradigm shift. To understand how meta-reward modeling, or MRM, actually works, I want you to think of it like a master tailor. Instead of taking every single measurement from scratch, the system uses a bi-level optimization framework. Notice how it relies on a shared weight initialization. The model is learning a highly adaptable starting point, so when a new user shows up, it is already primed to adapt instantly. Think about it. A standard tailor might need to measure every single inch of you to make a suit from scratch, but a master tailor, they've seen thousands of bodies. They understand the underlying geometry so well that they only need like 3 or 4 quick measurements to craft a suit that fits you flawlessly. That is exactly what MRM does for AI alignment. Let's break that complex math down into 2 very straightforward steps. Step 1 is the inner loop. This is where the model essentially mimics adapting to you, the individual, using just your sparse, few-shot feedback. It tweaks the specific weights just for your profile. Then, step 2 is the outer loop. The system takes what it learned from adapting to you and uses it to update the shared initialization for everyone else. It literally improves its baseline starting point. By constantly practicing this process of adaptation, the model captures the intrinsic commonalities of human preference. It is quite literally learning how to adapt.
Moving on to Section 3, leaving no user behind. Now you might be wondering, what happens to users with truly unique, unconventional, or maybe just highly specific tastes? Well, the tragic irony of standard meta-learning is that it tries to treat everyone equally to maximize its average overall performance. But if you treat everyone equally, the system naturally prioritizes the majority, right?
just to keep its average error rate low. So if your preferences are wildly different from the mainstream, standard meta-learning will essentially just ignore you.
You end up exactly like a frustrated user flagged as a lost cause, a quote-unquote hard-to-learn user, getting poor, really inaccurate results from the AI. The researchers recognized that leaving unique individuals behind was just totally unacceptable for a truly personalized system. So, to prevent the model from abandoning these outliers, they introduced an absolutely ingenious mechanism called the Robust Personalization Objective.
This Robust Personalization Objective, or RPO, acts as the heroic fix here. First up, it dynamically identifies hard-to-learn users by looking at query losses. That's essentially the system's error rate when it's trying to understand you. If the model is struggling to get you, your loss score goes up. Second, it uses user-level filtering. During those outer loop updates we talked about, the system explicitly forces the model to focus its attention on the hardest cases, the very users who are at risk of being left behind. Finally, it uses a soft reweighting technique. It smoothly shifts the training attention toward the underdogs, but without completely discarding the easy-to-learn users. This prevents the whole training process from destabilizing, and it guarantees consistent, robust performance for absolutely everyone.
Let's move to Section 4, testing the meta model, and see how this builds out in practice.
The researchers actually ran some extensive experiments to prove this isn't just academic theory. They used two highly regarded preference datasets, PRISM, which has these rich multi-turn conversations, and Reddit TLDR, which contains user preferences for text summaries. Distilling this dense data down, I was actually blown away to see the leap in accuracy when comparing the standard, non-personalized baseline against our new MRM system running on Skywork V2. Look at this. In the PRISM dataset, overall accuracy jumps from 64.4% to 65.3%. And in the Reddit TLDR dataset, with just 100 examples by the way, accuracy leaps from 67.8% up to 69.6%. Across the board, whether the users were seeing during training or were completely new and unseen, MRM consistently and significantly outperformed the non-personalized baseline. It really proves that this meta-learning objective is uniquely capable of extracting deep personalization from super sparse data.
So, the crucial takeaway here is that MRM enhances few-shot personalization and genuinely improves user robustness. It fundamentally solves that sticky dilemma we outlined at the very beginning. By learning the actual process of adaptation rather than just awkwardly memorizing data, it successfully leverages limited, real-world feedback. And it does this without ever sacrificing the fine-grained, bespoke personalization that we all actually want from our tech. Plus, thanks to that robust personalization objective, it ensures that no matter how quirky or unique your preferences are, the AI is going to learn to speak your language.
Which leaves us with one final, pretty profound question to chew on. How will this idea of learning to learn redefine our relationship with technology? You know, we are rapidly moving away from an era where we have to awkwardly adapt ourselves to the rigid constraints of a machine. Instead, we're entering a future where AI acts like that master tailor, instantly, seamlessly, and perfectly adapting to the contours of your unique personality with barely any effort on your part. Just think about how much friction that will remove from your daily life, and honestly, how much more powerful your digital tools are about to become. Thanks so much for joining me for this explainer, and I can't wait to explore the next big breakthrough with you soon.